In this section we're going to have a somewhat more detailed look at how the behaviours of indirect activation on the basis of path simultaneous expansion are selected. And as for most behaviours, the selection process involves the basal ganglia. Cortical receptive field detections have recommendation strengths in the striatum in favour of many different behaviours, including indirect activations. The most strongly recommended behaviours are selected, implemented by the thalamus, where implementation involves placing a frequency modulation on the outputs from a specific cortical area, so they're released to another area in the sense that the modulation greatly increases the effect of the outputs on the target. So, going back to the neuron connectivity that support this kind of indirect activation, and I'll stay with the parahippocampal cortex example used earlier, deep-level neurons in, say, the parietal cortex are the ones activated to generate the memory experience. In any actual direct sensory experiences, there's a set of neurons like this activated, and if you can reactivate that set, it will be like re-experiencing the event to some degree, and in particular, they have all the recommendation strengths that they had during the sensory experience, including recommendation strengths in favour of describing the experience. Outputs from the P3 population in the parahippocampal cortex drive those indirect activations. So, focusing attention just on those two primary neuron populations, the deep parietal cortex neurons that target the P3 population and the P3 population that targets the deep neurons. Now, the generation of an episodic memory involves two releases of cortical outputs. First, the release of deep cortical outputs to the P3 population. What's happening here is that during an earlier experience, some population of deep cortical neurons was active. Now, another population has been activated, perhaps via some trigger words, that includes a small subset of the earlier population. And the aim is to have that subset drive activation of a much larger subset. The outputs from the P3 neurons that are activated by the subset then have to be released back to the deep cortical neurons. And of course this diagram just illustrates one neuron in each of two large populations, and these releases are between populations of neurons. So there are two release behaviours that must be selected in the correct order. But let's focus on the release of the P3 population to the deep parietal neurons. These releases have to be recommended and selected in the basal ganglia. The P3 neurons themselves must have recommendation strengths in favour of their own release. The deep parietal neurons could also have this type of recommendation strength, and also output some other cortical areas that are able to discriminate between situations in which episodic recall is appropriate and situations where it isn't. Receptive field detections in those other areas might occur in response to groups of words that contain words like "what happened when" and so on. So there'll be lots of active inputs, and those inputs will go to striatal neurons corresponding with release behaviours. So for simplicity, I'll limit the illustration to just one P3 input, but all the inputs will have individual synaptic weight, which is a recommendation weight in favour of the release behaviour. Then in the usual way, outputs from the striatal neurons go to the GPI-SNR, and I've illustrated that path by a double line arrow to remind you that it's got both the direct and the indirect paths plus some feedback. Then the selection is communicated to the thalamus, and the thalamus imposes a frequency modulation on the P3 outputs, and of course there's the thalamic reticular nucleus in that route. So if the behaviour is selected, the P3 outputs are released to the deep parietal neurons, which implements the indirect activation. If there's reward feedback following the indirect activation, in other words, if receptive fields are detected by the cortex that correlate with positive consequences for recent behaviours, then any recently active synaptic weights onto the striatal neuron are increased, which increases the probability that an indirect activation will be selected in similar circumstances in the future. So again, this pattern of neuron connectivity can support selections of indirect activations without requiring neurons to have cognitive type information, anything beyond the information provided by their inputs.